Welcome back. We're now at Lesson 8A, titled More Water Please. When preparing for Lesson 3, you read an article about the importance of water to your brain function. The article stated that the average person in the United States drinks less than a quart of water a day. Yet, according to the Mayo Clinic, the average adult loses more than 80 ounces of water a day through sweating, breathing, and eliminating waste. So let's say you're currently drinking 16 ounces of water per day. I'm going to go ahead and underline that. It's probably going to do the crazy line. You're drinking 16 ounces of water per day, and you plan to increase your daily water intake by 4 ounces per week. Determine how many weeks it's going to take you to reach 80 ounces of daily water consumption, and then justify your response. This is a great time to hit pause, play around with this number with your calculator or with drawings, and then come back and we'll work on question 1 together and get going on this lesson. There are various ways that you can calculate what you are planning to do or how to do, and that's what the lesson today is about, whether you're talking about building a graph or building some kind of table, or just grabbing the calculator and doing stuff like, if you're trying to get to 80 ounces and you're currently at 16, when you subtract, some good old subtraction here, you've got 64 ounces that you need to gain. And so if we're doing this, that we want to do that as a daily water intake, but how many weeks if we're going to increase your daily intake by 4 ounces a week? One thought is that we could divide 4 into 64. And we'll get that we have 16 weeks. In other words, just a side thought, if we started with our 16 ounces, and then if we're going to, that's our current, and we plan to increase it 4 ounces a week, then at week 1, we would increase it to 20. And at week 2, we would increase it to 24. And week 3 to 28. And what we're saying is eventually by week 16, we would be at week 80. It would be good to double check this, but the idea is 16 weeks to reach our goal. The objectives for this lesson are that you'll understand that mathematical relationships can be represented in different ways. And throughout your mathematics career, you've probably seen these, but this lesson is going to put them all together to notice that we can take the same data and represent what's going on in different ways. We are going to talk about a linear relationship, and you would want to add this rate of change to your list of vocabulary or a Google document, flashcards, whatever it is that you have started in learning the words for this course. We're going to be able to investigate and compare mathematical relationships using a variety of representations. And we're going to create those representations to describe these mathematical relationships. And then we're going to write a linear equation once we're given a slope and a y-intercept. The scenario described is an example, the one we described in question number 1, of a mathematical relationship or a relationship between two variables. And I'm still in the wrong color. Two variables. In this example, one variable is time, the weeks that we're going to be increasing 4 ounces, and another variable is the daily water intake itself, which are the ounces. Mathematical relationships can be represented in 4 ways. This would be good to add to your glossary or your Google Docs, etc. So the first way we can represent mathematical relationships is verbal, where someone's describing a scenario. In addition to verbal, we have numerical, where we can list a table of data. And the table could look something like this, where we're talking weeks and we're talking ounces. Graph, and they lend one to the other, because we can then take the data and we can graph it on an XY coordinate plane, or, as you've seen, many other forms of graphing. And symbolic, where we can put it in an equation, y equals mx plus b. So we have algebra, we have chart or tabular, and we have graphical, and then we have verbal using words. Each of these models or modes of describing the relationship is called a representation. And the process of using one or more representations to describe a mathematical relationship is called mathematical modeling. This is definitely when you need to hit pause and go ahead and complete some of the questions, especially number 2, because that's what I'm doing next. And you can go on through question 6, but just make sure you're doing your part before you listen to the video. Starting at question 2, in our scenario in week 0, we are drinking 16 ounces of water per day. As each week progresses, we add 4 ounces to our daily water intake. Part A asks us to complete the table of data below for this relationship. Extend the input values for the weeks to complete the table and calculate the daily water intake. If we're going up by 4 ounces, week 1 we would be at 20, week 2 at 24. To complete the table given, we would then be at 28, add 4, add 4. Part B, what amount of change in water intake, is from week to week? The amount of water changed from week to week, and there are many things that you can do. You can write all over these charts that we're going up 4 ounces, up 4 ounces. Many things that you can do. You can look back up here to what we were talking about is going on, but the amount of change is that we are increasing 4 ounces of water per every week. Remember, we're looking at different representations. We just put information in a table, and now it says consider those data points in the table and plot these from the table on a grid in your notebook. Oh my, I'm going to erase that one. So I'm going to do mine right here inside of our lesson, and that one doesn't look much better. But I'm going to get us a coordinate plane going. And I'm going to look back at the table and notice that we had a 0, and we had a 1 week, and a 2 week, and a 3 week. And a good rule of thumb is that your time, if you have something with time, like in this case, it is weeks, will most likely go on the x-axis. And then the other item, the item that is dependent on your weeks, and dependent is going to be on the x-axis and dependent on the y, and this is going to be our ounces. So at 0, we were at 16 ounces, week 0. And then you can be very detailed. You can be very creative, like right now, and I could probably put like a little mark here that I'm not really starting at 0, I'm just jumping up here at 16. But at 0, I'm at 16, and at week 1, I'm at 20, and at week 2, I'm at 24, and at week 3, and you get the idea. Even though mine has a little bit of a curve in it, part B says, is this linear data, why or why not? Well, it is linear data because the y coordinate increases by the same amount each week, and we will be talking about a slope. In other words, we are going to go up 4 ounces for every 1 week that we advance. This is going to be a slope, and it is representing a linear change. But I'm going to scoot down the page just a little bit, and part C says, should you connect the points? Why or why not? And we need to think about this because our normal instinct is to just draw a line and connect all of the dots, but think about the data and what it really represents. We are not doing this graduated, like we're not doing on week 1. On Monday, we're not drinking 1 more ounce, and on Tuesday, 1 more ounce. We're committing that the entire week 1, we will be here at 20 ounces the entire week. And there's not something that's in between. We are literally going to the week 2, and our next amount is at 24 ounces. So no, we're not going to connect the dots because the problem talks about what happened at week 1, and then at week week 0, and then at week 1, and then at week 2. And it doesn't make sense with what we're looking at to talk about week 1.5. But the next question says, what is the rate of change? Oh, I'm sorry, part D, what is the y-intercept of the graph? And you may have had algebra classes before, and you may glaze over when someone starts talking about y-intercepts and slopes. But this is a really, really cool opportunity to figure out, learn, grasp a y-intercept. And a y-intercept is where we're going to go through the y-axis. Where are we intersecting the y-axis? And we are sitting right there on the y-axis. Notice what the question says. What is the y-intercept? We are sitting on this y-axis at 16. And so our y-intercept is going to be 16. That's where we cross that axis. Next part, part E, asks what is the rate of change or the graph of the graph. And I've already alluded to that looking at our numbers over here. Our rate of change. When you've talked about slope before, you probably talked about rise over run, or something like maybe delta y over delta x, or you probably had a formula. But this is really cool that you start to see that for every 4 ounces we go up, it's representing 1 week. 4 ounces up, it represents we are going over 1 week, or for every 1 week that we go over, we are increasing 4 ounces. 1 week, 4 ounces. So our slope is 4 ounces per every week. And I'll go ahead and write that down over here. The rate of change, put that one in your vocabulary, or the slope is we have an increase in 4 ounces per every 1 week. And using words is going to be very beneficial in everything we do in this course. So in question 4, and again, if you have not been hitting pause and completing the questions before watching the video, stop right now, go look at least question 4 and maybe further, and then come back and let's work this together. This says, consider the information from the graph. And when we were looking at the graph, we had weeks and we had ounces. And then we had our dots going up like this. It says, write a linear equation that represents the relationship between the weeks and the ounces of the water. Be sure to label your variables. I know in an algebra class, you probably always saw a formula like y equals mx plus b using y and using x. But you have permission to change those up. You could use something like W for the X for weeks, and then you could use something like I for intake for the Y for the ounces. With that being said, from the last question, we found that the slope is 4. It's 4 ounces for every 1 week. And we also found that our our y-intercept is 16. We cross the y-axis at 16. And with these 4 pieces of information, we can create a linear equation that represents this relationship. I will go back to y equals mx plus b. And instead of y, we could put I for intake. In other words, I is representing our y-axis, and it may make more sense by saying our intake is worth. The slope, well, we found that the slope is 4. And instead of saying X, we could say W. 4 times every week plus, where are we starting? What is our y-intercept? Well, it's 16. And we now have a pretty nice equation that says intake is worth 4 times each week plus the 16 where we started. With that in mind, part B says, let's do a calculation. So question 1 asks us just to play around with and figure out how long it would take. But if we've got an equation, we can do it very quickly and exact. to find the number of weeks. So we're looking for the W. How many weeks is it going to take to reach an intake of 64 ounces? So you would always want to rewrite your equation. In this case, it's I equals 4W plus 16. I don't have a lot of room, so I'm not going to rewrite it. I'm just going to point it out, and then I'm going to write down that 64 is my intake. And the question is, how many weeks? Well, I don't know that, so it has to stay in my equation, but I can keep writing the other parts of my equation. Now it is, I would say, simply solving, but that's not always the case. It may sometimes be a little bit of a chore, but in this case, we're going to subtract 16 from both sides. And when we do, this number looks very familiar to what we had gotten earlier. Here's a 48 equals a 4W. It doesn't seem like I got 48 a while ago. So looking here, I will now divide both sides by 4. And my W is going to be worth 48 divided by 4. Yeah, something's different here, and I got to figure out what I'm doing wrong. I'll be back. Okay, I'm back. I went back to look at question 1. In question 1, we were trying to get to 80 ounces, not 64. That's why everything is looking different. So using our equation to find out how long it's going to take us to reach 64 ounces, once I find my W is worth 48 divided by 4, I find that it's 12, and 12 represents weeks, so an answer would be, to get to 64 ounces, it's going to take 12 weeks. So now we're at question 5, and I'll go ahead and put 6 with it. You've now seen each of the 4 representations. The introduction and question 1 is the verbal representation of this scenario. Now they want us to go back and look at, so question 2 is going to be, and when you go back and look at question 2, it was a table. So we can use the word tabular, or we could even say it's numerical. We were using a bunch of numbers. There we go, numerical. Question 3, when you look back at question 3, that was where we drew the graph. So we'll call this one the graphical representation. And then finally, question 4, it is the algebraic representation, or you might even want to say it's the symbolic, because we used a lot of symbols. Use each of the 3 representations to attempt to answer the question, how many weeks will it take to reach 80 ounces? So I'm going to bounce back to all 3 of them, starting with question 2, tabular, looking for 80 ounces. So to use tabular, we're going to have to keep going on our weeks, and going on our weeks, and going on our weeks, and going on our weeks. I think you get the idea. And ta-da! 16 weeks using the table will get us to 80 ounces. Let's go look at the graph. So to find the 80 ounces and how many weeks, we already know it's 16. But to find this answer, I've got too short of a graph. So I'm even going to come back over here, and I'm going to draw a graph again with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 weeks. We already have a heads up on that one. And then 16 and 20 and 24 and blah, 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 until we get up here at 80. And so all of our, there should not be a curve, but I have a nice little curve going there. And so we would eventually get up here where 16 weeks and 80 ounces intersect. So we could do this graphically. And finally, we could calculate how many weeks it's going to take using our equation. So it's going to get really ugly. I'm just going to write it on top of everything that here is our equation. And we are looking for an intake of 80 ounces. That's the 4W plus the 16. We'll subtract 16 from both sides. This is where it went awry a while ago. Okay, freaked out a little bit. Something wasn't working. Getting the 64 equals the 4W. Can't even write that. Come on. Divide by 4, divide by 4. And the weeks with 64 divided by 4, we're going to find that we need 16 weeks, which we already knew, but the idea is to show you what it would look like with a table, with a graph, and with an equation. So now on question 6, they're asking us to list some advantages and disadvantages for each one of the 4 representations. So hit pause and take a moment to think about what you like and what you don't like about each one of these representations. A thought could be that it does take a long time to complete that table up through the 16 weeks, and it took a really tall graph to show the 16 weeks. The algebraic equation can be much faster, but it can take a while to get the equation set up. So you write down some personal choices on why you like these and why the verbal is good, but disadvantages of verbal. And this finishes lesson 8A. Look at your syllabus to see if you have any more lessons to complete this week. If you do, keep looking at videos, and if you don't, it's definitely time to go ahead and look at the homework. But wait, there's one more thing. This is the last call for you to complete this survey. You're going to circle one of these answers, and actually you're just going to email that to me. So looking at, I have learned very little, I've learned about half of the material in this class, or I've learned almost everything in the class so far, you're going to send your number to my email address at stephanie.r.andrews@lonestar.edu. If you haven't already done that, stop right now and send it. Here's the last call for it. Again, if you need to do some more videos, get going on those. You definitely have some homework to get on. I'll see you at the next video. Bye-bye.